Alright guys, this is just a disclaimer to say this video was filmed with me thinking my headset was plugged in, and it was not, which means there's some annoying tapping and so on, but I don't have time to change it right now. Perhaps in the future I will, perhaps I won't, but I promise the other videos are and will be without that annoying clicking sound. Alright, welcome back to Maths with Mr. Rowe, and we're looking at Unit 6 decimals today. Very fun. Okay, remember you can watch on faster speed, you can skip over everything you don't need to know, and we'll be good with that. So, the first thing we need to understand, it should be fairly simple, is that the way the decimal point works. So you see here, and I've got to take that off that, here we go, we've got, before the decimal place, before you ever worry about these, you should all know this. Ones, tens, hundreds, 428, 400s, 2 10s, and 8 ones. But after the decimal place, they sort of go in the opposite direction. Now, there's no once, but there's tenths, hundredths, and thousandths. So they go the opposite way, and then it would be tens of thousands, then hundreds of thousands, and so on. We only really mostly, for the most part, we really only name tenths, hundredths, and thousandths, at least when we're using our final answers, because we usually have to go to the nearest decimal place. But that's more for the future. So that's the way that works there, and the section, as it says here, anything after the decimal point is basically a fraction. It's part of a whole. Okay, so that's the way that works. Now, the way we're doing that is that here, let's say you've got 1/10. So if you've got to turn this fraction into a decimal, you should know that it's a tenth. It's 1 over 10. It's 1/10. Therefore, you need a 1 in the tenths column. So you would simply write 0.1. Now that's the tenths column right here. That's the tenths column. Therefore you need 1 in it because there's 1 out of 10 there. Now the next one, 11 out of 100. Okay, that would be 11 hundredths. Now you're not going to put 11 in the hundredths column up here. It's just not going to happen. Basically what it means is there's going to be 11 that you're going to count before it. So for example, you may know that, for example, 428, it would be like 42 tens. Instead of saying 400 of the 2 tens, you could say 42 tens. They were this way, basically, 11 hundredths is 1/10 and 1/100th, and it works out to be 11 hundredths. So it would be 0.11, like that. So basically the way you do it, the way any read it, if it was like, well here, 111 thousandths is how you'd read that, 111 thousandths. Which means you just go 0.111. So effectively, this is the thousandths column here. So you just read the number and then say the last column that it's calling it out of. So if it was tens of thousands, you would say that's 1,110 10,000ths. That's basically the way it works. So you say the name of the last one, but you read the number otherwise. Now here's the tricky one here, 3 out of 100. You may think, well, easy, 0.3, but that's wrong because that is the tenths column, so that's not right. This is the hundredths column, which means you're going to need a 3 in there. Now, it's not 33, which means that should have been a 0, because there's nothing in the tenths column. It's only 3 out of 100. Now, what do we do then, though, when we have a whole number and a fraction when you turn it to decimals? Well, it's quite the same. Keep the whole number the same, 6, but instead of putting a fraction, you put point, and it'd be 4 tenths. So again, 4 in the tenths column, and so on and so forth. We'll skip over the rest, but the whole numbers stay the same. You don't worry, you just put them before the decimal point, but they remain the same. Now, how do we arrange decimal numbers in ascending or descending order? Okay, ascending, think up, ascending up, descending down. Okay, well, the first thing is you look at the first digit, whatever it is, and you make sure it's in the same column. So these all start with a ones column number. So we've got 3, 7, 2, 2, 7, 3. So obviously we're going ascending, so we want to start the smallest. So we've got 2 2s. So we're only looking at those now. Then we look at the second number. Now in the tenths column, it's got a 7 and it's got a 3. So obviously 7 is bigger, so we want the smaller one. So 2.37 will be 1. Then obviously there's only other 2. So it'd be 0.73. Then we go back to the drawing board and we look at the ones again. We've got 3, 7, we can cross these out. 3, 7, 7, 3. So we look at the threes. 3, 2, 3, 7. Okay, well obviously we want the 3, 2, 3.27, 3.72, and then we've got the 2, 7, 7 and 7, 2 and 3. So the 2 goes first, 7.23 and 7.32 is how it works. And you just go column by column, compare them as you go. Now, rounding. Now, you know that these round down and these round up. But when you round down, the number that you're looking at doesn't actually change, okay? It only stays the same, whereas rounding up, you actually have to change it. So here, if we round to say, I'll just choose some. Let's say we round to the 2 decimal places. So this is the one we're looking at. So we have to say that's what it's going to be. It's going to be cut off there. But so we look at the number after that cutoff, which is the 5, and we have to decide if that rounds up or down. Now here we know that 5 rounds up, which means the 4 will change to 5. 12.65. Okay. Let's say we're going to round this number to the thousandth. So that's the cutoff there. So this 9 is what we're looking at, and we look at the 3. Is it going to go up or is it going to go down? Well, it's going to go down, which means the 9 stays the same, and we just cut those off, or technically turn them to 0, 0, but that's how it works that way. Let me look at this one to make it a bit more confusing for you. 9. Is there a 9? There's no 9. Okay, I'm just going to write a number. Let's just say 4.696. And we want to round it to the nearest hundredth, which is this column here. So we draw the line. So this is what we're looking at, but we're looking over here to see whether it goes up or down. Now 6 goes up, which means that 9 will turn into a 10, but we don't write 4.610. That doesn't make any sense. This number is getting smaller. So what we do is we actually turn 9 to a 0, regroup the 1, it turns into 4.70 is what we want in that situation. Okay, plussing and minusing decimals. That's really no harder than just adding normal numbers effectively. So we look at this question here, you just want to line it all up. Line up the decimal places or whatever. So we've got 1.209 and 3.528. Now here's the deal. If there was no 28 here and it was just 3.5, you may want to draw in some zeros just so you keep yourself organized. You don't have to do that, but it's an option. So obviously you just go 1, 9 is 10, plus 8 is 18, 1, 7, 2 is 10, 1, 6, 8, 13, and 5. And we put the decimal place in the same way, and that's how you add it up. Okay, negative minus is the same way, 1.97, that's supposed to be 9, and 0.43. Just take that away. Obviously the small number usually goes second, but I should say that's not right because we're about to start our negative number unit, and that's going to change things up for you. So 7 minus 3 is 4, 9 minus 4 is 5, and 1 minus 0 is 1. That's very easy subtraction because there's no regrouping, but you should already know that already. Okay, 6D now. Now we're looking at multiplication of decimals. Now we know that when you times something by 10 or 100 or 1,000 or 10,000, what you're really doing is you move the decimal point. So here, if you times by 10, you move the decimal place to here, just 1 over because there's 1 0. So it would be 4,222.7. Here, be 2 zeros, so you go 1, 2, and you put the decimal place in there. Maybe I'll zoom in here a little bit. Here, times 10,000, okay, you go 1, 2, 3, 4. Now, because you've got empty ones here, you need to fill them with zeros. 0, 0. So, and the decimal point would go there. Don't forget to put the decimal point in. So it would end up being 3,400 or 3,400. Now, this little bad boy, he would go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So you fill them with zeros, put the points, and you cut these off. You don't need these zeros anymore. They're wasteful at the end because now they're whole numbers. You can't have zeros in the million, whatever column that is. Millions. Yep, millions. 10 million and 100 million. There's no point. So it really ends up being 516,000. Okay? That's how you do it. Decimals and dividing is the same way, effectively, but opposite. So you bounce the other way. So divide by 10, you go whoop, and there it goes, 35.31. Divide by 100, 1, 2, 10,000, 1, 2, 3, 4, and you do that, basically, is the way you work that out. Now, here, if you, let's say you have 34 and there's no decimal place, times 1,000, well, what you're really doing, and you would know this already, you just add the 4 zeros on, really, just like that. But what you're really doing is there's a decimal point there, even if there's nothing after it. There's always really a decimal point there. 34 is really 34.0, but we don't put that on because it doesn't mean anything. So what we're effectively doing is we move the decimal point 4. So 1, 2, 3, 4. We fill those with zeros, and you equal the same thing, which is 340,000. That would be the same. Well, actually, here the decimal point would be here, so we go back to 8.7. Here we'd go 1, 2, 3, 3 zeros. So we'd have the decimal point here, so 0.007. Yeah, double 07. Why not? Alright, 6E, how to multiply decimals, though, by numbers that aren't just tens, hundreds, thousands, or whatever. Basically, this works exactly the same as normal multiplication. We just simply times it, like you forget about the decimal, and at the end, you need to count how many decimal places are, which means how many numbers there were in the question after the decimal point. So here, we have 2 after the decimal point. There's nothing in 40, so we just do basically 252 times 40. Now 0 times all that is 0, so we're really doing 4 times all this, which is really 40, so we just add our 0 as always. 4 times 2 is 8, 4 times 5 is 20, to there, 4 times 8 is, 4 times 2 is 8, plus 2 is 10, and there we have the answer, but it's not 10,080, because remember, there was a decimal point there. You can put it in there if you help you remember, but just times it like a normal number. So there's 2 decimal places, so we need 1, 2 decimal places. So the answer to that is 100.80, which is really 100.8, because the 0 at the end means nothing. Okay, we don't have anywhere here where there's multiple decimal places on each side, but it doesn't matter. You just count up from both sides combined. So let's do this one, the bottom one. So it's just basically 34 times 200. Now these zeros mean nothing. Effectively, it'd be 0, 0, 0, 0, 0, because it'd be that one and then that one. But and then 2. Now because it's 200, you need to automatically add 2 zeros, right? And then you need to do the 2 times 4 is 8, 2 times 3 is 6, and you'd add it up, but it's just 6,800 the same. But remember, there were 4 decimal places in the question. So we go 1, 2, 3, 4, and we put it there, and it's 0.68. That's the answer to that. Now, dividing is a little different. You can't just do it like normal division. It'll blow you away when you do it on paper. What you have to do is you have to make the divisor, which is the one you divide by. This is the dividend, by the way, the one you're dividing, and the answer is the quotient. Just a reminder on that. But you have to make the divisor a whole number, okay? So you need to keep moving the decimal places until all the numbers that matter are in that, and you have to move the dividend number, the number you're dividing, the same amount. So here we move this once to make it 2, and we move this once to make it 61.4. So we do 61.4 divided by 2. So how many 2's in 6? There are 3. How many 2's in 1? There are 0. Carry the 1. We'll regroup it, whatever you want to say. 2 into 14 is 7. Put your decimal places in line. So there you go. originally 6.14 divided by 0.2 is 30.7. So the answer is the right answer for it. You just change the way you ask it. That's the same one, so don't worry about that one. This one here, let's do the bottom one. Actually, no, let's do this one here. So we've got basically, you need to move it 1, 2 to make that a 4, and then you need to go 1, 2 to make that the 0.32. So basically you say 0.32 divided by 4. So 4 is in a 0, 0 point, 4 is in a 3 is 0, 4 is in a 32 is 8. So 0.08 is the answer to that one. So you just remember you're making the divisor a whole number. So here would be 1, 2, 3, 1, 2, 3, so it would be 4003 divided by 5. You don't need to see that again. Okay, 6G, convert the following decimals into fractions in the simplest form. Now, this is not going to be in the exam at least in 2021, okay, when I'm making this video. It may change, but this is in the unit in the textbook, so I thought I'd just cover it. Feel free to skip over this part, but there may be some simple ones like this, but it won't be for simplest form. So 0.8, that's an 8 in the tenths column. You should know that's just 8 over 10. And for the purpose of the simplest form, really quickly, you have to divide, you find the biggest or the highest common factor that you can times both into 8 and 10. In this sense, it's 2. Okay, so you divide that by 2, divide that by 2, which would equal 4 and 5. Okay, so that's the simplest. You can't divide 5 and 4 by the same thing, so you'd be done with that. Okay, if I had, let's say 5.5, now again the whole number stays the same, you just put it there, and you've got 0.5, which is 5 tenths, 5 tenths. But you can divide both 10 and 5 by 5, so what you'd end up with is a half, so really you'd have 5 and a half. Okay, that's a brief overview, but that's what you'd have. And if you had like, well, 99.99 would just be 9 and 100, you can't simplify that. Let's say this one, that would be 8 over 100, but you can divide both 8 and 100 by 2, so that would then equal 4 over 50, and you could also divide that by 2 as well, so you could just divide it by 4 I suppose, but by that 2, so it would be 2 over 25 would be the simplified version of that. But that gives you an overview. We're going to cover more of that when we get to our fractions unit. Yay for fractions. Can't wait. Anyway, but this you will have to convert each of these fractions to decimals. Now, that's easy. That's just 0.9. We did that earlier because it's 9 tenths, 7.7, 0.79, and yada yada, 0.123. So easy. Remember this one. Not 0.3, but 0.03 because the 3 has got to be in the hundreds column. Now this one though, you've got more. So people are like, what do I do with that? Well, you've got more than the denominator, which means you've got a whole. So you take 100 out of 121, so you really have 1 and 21 out of 100. But then you need a decimal, so it's really 1.21. That's how it works then. Alright, here's where the fun begins. This is probably one of the hardest things in the test, if not the hardest. You can turn any fraction into a decimal by dividing it, okay? And you don't need to know. There's a simpler way if you can get it to be, like, for example, if you had 1 out of 5, you can make it equivalent to out of 10. So you can times that by 2 to make it equal 10, which means if you times that by 2, you'd equal 2. So 2 out of 10, quite simple, 0.2. Okay, so if you can turn that, if you had something out of 50, say 11 out of 50, you could times that by 2 and it would equal 100, and then have times this by 2 is 22 out of 100, and that would be quite easy, 0.22. Okay, you could do that. But here, this is 3 out of 6 is a bit harder. So what you do is you divide the numerator at the top by the denominator at the bottom. So you say 3 divided by 6. Now you can't put any 6s in the 3, so you'd have a 0, but then you put a decimal point and you add a 0. And you obviously can do the little 3 there if you want. How many 6s in 30? You'd have 5, put the decimal point there, 0.5. Now you can keep doing that forever, and these will show you the examples. So 1 out of 3, okay, would be 3, or 1 divided by 3. Now, you know you can't do that, but you put a decimal point and put a 0, and that'd be 10. How many 3s in 10? That'd be 3, with 1 left over. And you add another 0, 10, 3, with 1 left over, and so on and so forth. And then you figure out it would just go 3 forever. And remember that really just means you just go 0.3 repeater up the top. Now 3 out of 7 is where it gets fun, alright? Because you've got to do 3 divided by 7. Now, you can't do that obviously, so you put a point and 0. How many 7s in 30? 4, because 4 times 7 is 28. Okay? 28 to 30, how many leftovers? There are 2. But you need another 0 first. 2. 20, how many 7s in 20? There are 2. 2 times 7 is 14. With 6 leftovers, 6, add another 0. 60, how many 7s in 60? There are 8. 8 times 7 is 56. Okay, I know I'm a maths genius. And then there's 4 left over from that. Another 0. How many 7s in 40? There are 5, because 5 times 7 is 35. Leftovers between 35 and 40 would be 5. Another 0. How many 7s in 50? There are 7. With 1 left over with a 0. How many 7s in 10? 1, because 7 times 1 is 7. And 3 left over again. And what do I notice? I'm back to 30 and 30. So if I actually kept doing this, I would have this forever. 4, 2, 8, 5, 7, 1. 4, 2, 8, 5, 7, 1. And you just go on forever. And so the book says that this is the right way to show that, because it's like ... repeater. So all those numbers repeat over and over and over and over and over again. Now, I don't know if you know this, but once you get down to about the thousandths, that's why we rarely round for longer than that, it's very inconsequential. Like if this was money, that'd be 42 cents, 42.857 cents, less than a cent. It's not going to really get you anything. Even a cent's not going to get you anything, so we don't really care about that. So we usually round it to the top, money would be 2 or whatever. So now I realize if it was an astronomically big number, it would maybe mean something, but not right now. Okay, moving on. 6H. Oh, we're nearly done. Look at that. Express the following percentages of decimals. Now this is probably the easiest thing you can do in this unit. And here we show that if you have a decimal, you times it by 100 to get the percentage. If you have a percentage, you divide it by 100 to get the decimal. And we know that when you times 100 and we divide 100, you just move the decimal place. So let's do the top ones first. Maybe you drop the, if it's 27%, you need to divide, because really that means 27 out of 100. So you just need to drop the percentage, which means there's like a decimal point there, and divide by 100. So 12.27, 12.68, 12.54, 12.85, 1.99. So that's still more than a whole, but it was 199%. 1.42, 12. Remember, you have to fill it with a 0, so 0.09. Okay, 12, fill it with a 0, 0.06. You have to do that. Alright, express the following percentages as decimals. These are the same thing really as there, but they're smaller. So you go 1, 2.3333, 1, 2, 1.5, 1, 2, wait, that's not what that is. 1, 2, put a 0 in, so 0.0104, and so on. Right, 1, 2, 0, so 0.00025%. Actually, not percent, just point, because you've got to drop the decimal. The percentage, obviously, that's what we're doing. We're changing them to decimals. Okay, and I didn't put in, obviously I'll write some in now. You've got to do from decimal to percentage. So if I have 0.27, it's the other way, 1, 2, and you write a percent sign, 27%. If I have 0.03, you would go 1, 2, and write percent. Okay, now you do keep the decimal place the same. Like if I had 0.33221, and I said, all right, well, you go 1, 2, so it's 33.221%. So when you turn into a percentage, you need to add the percentage sign. When you turn from a percentage to a decimal, you need to take away the percentage sign. That's a reminder. Alright, don't forget to like and subscribe, and I hope you got something out of this video.